Now I am asking another presenter to present his paper, Determination of Formaldehyde urea mole ratio affecting some properties of particle board manufactured with mixture of melamine impregnated paper wastes and heat urea formaldehyde resin. Line is yours. I'm sorry I can't spell your second name, Halil. I can.
Yeah, it's no problem. Can you hear me?
Yes, we can hear you. I'm asking you again to pay attention on time.
Okay, I will be quick. Thank you very much for your presentation. And I will present my paper, the title of Determination of Formaldehyde and Euro-molecular effects on some properties of particle board manufactured with mixture of melamine impregnated paper waste and neat Euroformaldehyde resin. And first of all, I will introduce myself. I'm from Kütahya Dumlupınar University, and it's the Faculty of Technology, Wood Product Industrial Engineering. And we can continue my presentation. This is the contents, but I think I will be quick about the introduction. Particle boards are the large surface boards produced by the combining chips and thermoset resins under the high temperature and pressure. And the most commonly used adhesive in the particle board industry is the Euroformaldehyde resin. I'm sorry. Yes. I think. Can you see?
We don't see full screen of your presentation.
Yeah. I think it's about I shared. I used two screens, so it's about this. We can continue like this. Is it okay for you?
Okay.
Okay, I will continue like that. And the most commonly used adhesive in the particle board industry is the Euroformaldehyde resin. The formaldehyde and euromolarity of the UF resin has a significant effect on the formaldehyde emission during the producing and also final products. In addition, the physico-mechanical properties of the boards are also affected by the molar ratio. And what is the melamine impregnated paper? They are the decorative papers used in the wood-based boards. I think I have to be quick. This is the main purpose of the coating particle board with MIP is to achieve a beautiful visual and also provides the best level of the protection of the board's moisture, provides better mechanical values compared to the uncoated board. It prevents the release of the harmful gases such as formaldehyde and pesticides. This is about how many wastes occur in a medium-sized MDF factory in the 1 year. It's the a medium-sized MDF factory with annual usage capacity of 420 million square meter of MIP, just approximately 2.5 million square meter of waste MIP is generated per year. And this waste contains the 60% of chemicals such as adhesive, curing agents and cross-linking agents, and 40% of alpha cellulose decor paper. And due to that chemical content, it's not suitable for the generating energy through the burning them. It is required special burning boilers at the high temperatures. And researchers have looked for alternatives to utilize these waste. And from our previous studies in the particle board, which produced with the MIP waste, as an adhesive, with the rising of the MIP waste, formaldehyde content was also increased. And the aim of this study was to investigate the formaldehyde euromole ratio effects on the some properties of particle board manufactured with the mixture of these two adhesives. Exactly the formaldehyde emission properties, we checked it. On this purpose, we produced 3 layers particle boards, and formaldehyde contents, mechanical and physical properties are determined and in accordance with the standards. We use, this is the material and method, we use fine chips for the surface layers and the coarse chips for the core layers, and 67% of the total board weight was accounted for the core layer, and for the surface layers were contained just 33% of the total board weights. As you can see from here, that one is has a cooling capacity. This is the pulverization machine. We just first MIP wastes were milled with this machine and separate into the dimensional classification. And the MIP waste floor screen and paste from the 0.2 millimeter sieve were used for our study. And UV resin also used as an adhesive. It contains the 65% solid contents, and ammonium chloride with 25% solid contents used as a hardener. And this is, I think, very small, but I don't know, can you read it or not? The experimental design, this is, we use for the surface layer UF resin 12%, and core layer 9% of UF resin, and this is the 1 mole Euroformaldehyde resin group, and this is 1.20 mole Euroformaldehyde resin group. If we take UF resin, MIP was added as much as the resin removed. You can see from the experimental design. And depending on the experimental design, particles, MIP waste, UF resin, and hardener were dry mixed in a high intensity mixer, and for the produce a homogeneous blends. The blends were laid into frame of 500 millimeter cross 500 millimeters, and you can see from here our mat. And this is the production parameters. Pressure, it's 0.4 or 6.2 megapascal pressure, and target thickness is 19 millimeters. Press temperature is 200 Celsius, centigrade Celsius, and press time is the 240 seconds. After pressing, particle boards were conditioned at a temperature of 20 Celsius, centigrade Celsius, and 65% relative humidity. And the conditions board were cut from 4/8 and grinded thickness range of 0.40 and 0.80 millimeters. Then test samples were cut according to the TSEN standards. I can see from here 9 samples for each group and 3 samples for each manufactured boards were examined for all properties testing, and mechanical properties testing were performed on Zivik. You can see from here our universal test machine. And the design expert version was used for the statistical software program, was used for the statistical analysis. And result and discussions, we can see from here the density instruction graphs for our boards. Density of the manufactured panels were in the range of the 720 and 760 kilogram per cubic meter. And the statistical analysis showed that while formaldehyde and urea mole rate had a significant effect on density, and MIP waste amount did not. With the addition of the MIP waste, you can see from here, density values were slightly changed. When the graph was examined, it was observed that the density values were close range to each other in the same mole ratio groups. If the graph examined as formaldehyde and euromol ratio, the boards groups which produce with 1.25 mol resin has higher density values than others. We thought that it is about the internal adhesion of the boards. And this is the formaldehyde content. Formaldehyde and euromol rate had a significant effect on the formaldehyde contents. The usage of the MIP waste in the manufacturing shows some waves in the formaldehyde content interaction graphs, but it was determined that the amount of the MIP waste had no statistically significant effect on formaldehyde content. Just 1 mol resin groups were satisfied standard values. Internal mol properties, and based on the result, both formaldehyde and euromol rate and MIP waste amount had a significant effect on IB strength values. With the addition of the MIP waste, IB values of 1.25 mol resin groups are more influenced than 1 mol resin. In the 1.25 mol resin groups, you can see from here is the green color, 1.25, and for the 1 mol resin is the red one. In the 1.25 mol resin groups, loading of the MIP waste caused the decline in the IB values you can see from the graphs. And in the 1 mol resin groups, while with the first loading IB values were not changed, with second one, IB properties were improved. Moreover, all groups manufactured were satisfied standard values, and more than twice the values was obtained. I will summarize all data from the last page, I think, of my presentation. Yes. And bending strength. With the rising of the MIP waste amount, bending strength values were mostly increased. However, MIP waste amounts have not significant effect on the bending strength. The size of the MIP waste were very small, and it included small pieces of the alpha cellulose paper. It was thought that it helped to improve bending strength properties. However, in the 1 mol resin groups, which has highest amount of the MIP waste, shows lowest bending strength properties. In this group, with MIP waste loading, bending strength values were declined. All manufactured groups were satisfied standard requirements for bending strength. It's about 13 megapascal. Formaldehyde and euromol ratio was found statistically effective on the bending strength, and 1.25 mol resin groups shows better bending properties than 1 mol resin. And modulus of elasticity from the interaction graph, both form and euromol rate and the MIP waste amount had a significant effect on mol values, modulus of elasticity values, and the 1.25 mol resin groups provided better modulus of elasticity values than 1 mol resin groups. Moreover, all manufacturer groups reached the standard values. It's about 1,600 megapascals. And
Mr. Halil, I'm sorry, I must warn you on time.
Okay, I will.
Please be focused on conclusions.
Okay. Surface. I can pass from the summary of the work. You can see from this table for the formaldehyde content, just 1 mol ratio of the resin groups provided the standard requirements for the E1 limits, E1 class formaldehyde emission class, and all the manufactured groups they provided the standard requirements for IB or bending strength or modulus of elasticity or surface soundness or the screw withdrawal strength, but except the thickness swelling but they also provided for the standard for water absorptions. And from the table, it was clearly seen that both the mold-retive resin, which has MIP waste, were satisfied the standard requirements for mechanical properties and also water absorption properties, except thickness swelling properties, while 1.25 mold-retive resin groups had a high level of formaldehyde content, more than standard. 1 mold-retive resin groups were satisfied the standards. As a result of this study, it can be said that the MIP waste might be utilized with different mold-retive resin as an adhesive in the manufacturing of particle board. However, more work needs to be done with a different rate of MIP weights for using with 1 mold-retive resin. And this is, we want to thank you, the Ministry of Science, Industry and Technology in Ankara. This is our project number. And we would like to also thank the Customer Integrated Adana MDF facility for providing waste melamine impregnated paper and chips. Thank you for your attention and patience.
Okay, thank you for your presentation.